Looking at number 53, this seems like a fairly sophisticated problem. That's supposed to be a minus sign. I'm supposed to find the angle between the solution sets of these two algebraic equations at their point of intersection. I've started this sentence very hopeful that this can be done without too much trouble, but let me think for a second about whether or not that's going to be the case. I've got y is equal to x squared. Solution set is a familiar parabola. 3 halves minus x squared, that's a parabola's top is at 3 halves, and it cups down. Oh, there'll be 2 points of intersection then. Okay, so let's take a look at this one. Right there, there's a tangent line to this concave down parabola, and associated with that is a slope. And that slope can be the components of one of the components of that vector. So slope is rise per run. So let's see, if we have a run of 1, then whatever the rise is should go right there. I'm anticipating that being a negative number. We'll have to figure out what that is. And then similarly for the concave up parabola here, there is some tangent line, and along that tangent line lies a vector. And the components of that vector will be 1 unit of run, and then the amount of rise associated with that will go over there. So that's what I'm aimed to figure out. First off, let's try to find the point of intersection of the solution sets of these two guys. That's it. We're trying to find this point. Okay, we're just trying to find both the x and y coordinates of that point. Let's see. At their point of intersection, how can I describe this? First of all, the point of the intersection is where x is such that you can substitute this expression for y into this expression of y, and that'll give you just a description of x. Let's see. Such that. Okay, so if I put this expression inside of that one, I'll get 3 minus x squared is equal to x squared, which is equivalent to, let's see, 2x squared is equal to, oh, I forgot the 3 halves. Okay, so 2x squared is equal to 3 halves, or let's see, x squared is 3/4, or x is plus or minus the square root of 3 over 2. And that means that y needs to be equal to x squared. So, and y is equal to x squared, which is simply 3/4. So now I know where that point is. That is where x is square root of 3 over 2 and y is 3/4. Good. But that doesn't tell me the value of the derivative. So now I need to think about how to get that derivative. Mostly now I'm thinking about how to word the sentence. How about this? Can be determined by their slopes to these points. dy dx at these points. And those two slopes are, so what's the derivative with respect to y of that expression? 0 minus 2x, and we need to evaluate that at this x value plus or minus the square root of 3 over 2. And that is minus or plus, notice I've changed the sign, square root of 3. And the other expression here, that is simply 2x, when you calculate dy dx, we evaluate that at plus or minus the square root of 3 and get plus or minus the square root of 3. Okay. So we'll say, now those slopes, minus or plus square root of 3 and plus or minus the square root of 3, they go right here in these missing components from earlier. For the concave up curve, that was that one. We had a tangent vector right there. This first component was 1, and second component should also be positive. It looks like it's square root of 3. And then this guy has a negative component, then it's a negative square root of 3. So, in particular, the angle is the inverse cosine, or arc cosine, of certain dot product. The dot product of that with this divided by their magnitude. So 1 square root of 3 over its magnitude, 1 squared plus square root of 3 squared, dotted with 1 negative square root of 3 over its magnitude. That was fun.